Chapter 10 regards structures of alkenes and reactions of alkenes. And Chapter 11 does the same for alkynes. Now, I'll cover both of them somewhat together because a lot of the reactions for alkenes and alkynes are very similar, if not identical. So as we talk about one, we'll also include reactions of the other. So we'll kind of be mixing both these chapters. So the most interesting piece of the structure for the alkenes and alkynes, obviously, is the pi bond that didn't show up in alkyl halides or alcohols. So that will be our new feature. Of course, these molecules have sp2 hybrid orbitals on each of the carbons that are as part of the alkene, which means that the geometry around each of those carbons is trigonal planar. And also remember that the pi bond is weaker than a sigma bond, so it's easier to break. So degrees of unsaturation is a tool that will be useful in helping us determine structures of molecules, a lot of times based on the molecular formula. So first of all, we need to talk about what saturation or unsaturation is. A molecule is saturated if it has the maximum number of hydrogens for each carbon atom. In a way, it also means that there's no rings or pi bonds. So then unsaturated just means less than the maximum number of hydrogens in a molecule, which means that there will be a presence of ring or pi bonds. So let's take a standard molecule and take a look at it first. So if I have butane, I've got 4 carbons, so C4. I've got three hydrogens here, 2, 2, and 3. So 3, 4, 5, 6, 7, 8, 9, 10. C4H10. That molecule is fully saturated. You can see there's no rings or pi bonds. Let's see what happens to the formula if I put a pi bond in. So now I still have C4, but now I only have 3 hydrogens here, 2, 1, and 2, 3, 4, 5, 6, 7, 8. C4H8. This is unsaturated. Let's do the same thing with the ring and see what that does. So now I have my C4 in a ring. C4, and in each vertex I have 2 hydrogens. So 2, 4, 6, 8. C4H8, that's also unsaturated. So what we say for each of these 2 molecules is each of these molecules has 1 degree of unsaturation. And that 1 degree of unsaturation is going to be equal to 2 hydrogens. Because it's got 1 element, 1 pi bond, 1 ring. So that's 1 degree of unsaturation. So we can look at these and we can determine a formula for what saturated is. So saturated compounds have a formula of Cn, so however many carbons there are is N, H, and if you look at the difference between here and here, it's 2 times N plus 2. So if N is 4, 2 times N is 8, plus 2 is 10. So H2N plus 2. So that's the formula for something that's fully saturated. So now we can compare against this if we know a molecular formula for a compound and determine the number of degrees of unsaturation. So let's look at an example, C7H16. So the first thing that we want to do is calculate what the fully saturated molecule would be. So C7H2 times 7 plus 2. So it would be C7H16. So that's the example that I actually used. So we could look at this one and say this is fully saturated. So now if you wanted to try and draw a structure of that, you know that it has no rings and no pi bonds. And you could make up a structure, 1, 2, 3, 4, 5, 6, 7. It could just be heptane, or you can make it somehow different as long as there are 7 carbons in it, no pi bonds, and no rings. What if I have C7H10? So the first thing, again, is to calculate fully saturated, which we already did up here, C7H16. And now I want to subtract from that. So I should have 16 hydrogens if it's fully saturated. I only have 10, so I'm missing 6 hydrogens. Remember, for every 2 hydrogens, that's 1 degree of unsaturation. So if I divide that by 2 hydrogens, I get 3 degrees of unsaturation in this molecule, which could be 3 rings, 3 pi bonds, or some mix of the two. So now I have to make up a structure that's got 3 degrees of unsaturation. So here I have 1 from my ring, and then 2, 3. I'll put 2 double bonds in my ring. So that's just one possible structure that I can draw, but it has 3 degrees of unsaturation. So that's how you use them. Now you had to do this in lab when we did mass spec, so you also saw that. So let's see how other atoms affect degrees of unsaturation. If we have a halogen, we treat that just like a hydrogen. Halogens make 1 bond, just like hydrogen does. So if I had C7H9Cl, that's the equivalent of C7H10, like the one that we just did, which had 3 degrees of unsaturation. If I have an oxygen, I just ignore it, because oxygens make 2 bonds, so they don't change the number of protons or hydrogens. So an example would be C7H10O. The equivalent of that is just C7H10. And the third common thing that we would have in molecules is nitrogen. And if we have a nitrogen, we actually have to subtract 1 hydrogen from the formula. And that's because of the way that nitrogen makes 3 bonds. So if I have C7H11N, the equivalent is, once again, C7H10. Subtract 1 hydrogen as we take off the nitrogen.